Hello and welcome to Fun Ahead TV. Thank you so much for joining. In today's episode, we're going to continue the multi-part series of rebuilding the transmission in my 2001 996 Porsche Carrera 4. We've been disassembling and reassembling this transmission to be able to completely rebuild and rejuvenate the second gear components. That's both the second gear itself and the synchro components for the second gear. This was due to a grinding that I was experiencing, which is very common in these transmissions as they get higher mileage on them. The cause of this is synchro wear. These synchro cones will wear down and you eventually get contact with the synchro sleeve and the gear itself before the shaft speed and the gear speed is 1-to-1, causing grinding. Anyway, in the last video, we rebuilt the stack from second gear on up. We have it to the point now where we're completely ready to finish reassembly on the transmission, which is very exciting. But anyway, on today's agenda, we are going to complete the reassembly of the transmission by putting back on the reverse shifter fork and the 1-2 shifter fork. From there, we can then reinstall the nose cone and get that set in place, which I have heard is quite the task. But we will deal with that together as we get there. And then finally, we will seal the nose cone up to the rest of the transmission housing. Then we can refill it. From there, it will be ready to reinstall into the car, which is super exciting. That means we're on the home stretch. So, with that intro stuff out of the way, let's get right into it. Just do me a huge favor and graze over that like button. Just hit it. Just hit it. You know, light it up for all to see. You know, it really helps me out. Really helps the channel out. And it just shows me that you guys are enjoying the videos that I'm putting out there. So thank you so much. Let's get back to the content. Yep, we're going to start by putting back in the shifter forks, which are these two here. So we have the reverse shifter fork, which goes onto this synchro ring here, and then we have the second shifter fork, which goes onto this synchro ring right here. First, I'm going to put on a little bit of assembly lube onto this brand new synchro ring. Now, if you missed in the last video, we basically here down is brand new hardware, including the hub, synchro sleeve, the detents, and all of the synchro ring hardware between the sleeve and the gear itself, including the gear. So all of this is brand new, and it does not have prior lubrication from when the transmission was previously put together. So I'm going to go ahead and just put a little bit of assembly lube, especially up into this sleeve here. I'm going to throw some onto the fork itself too, just to kind of aid in lubrication. A couple of things to consider with this for this reverse sleeve. This notch here is very critical. This notch is where this part goes. This is what selects which of these rods is actually going to be moving up and down, the rod selector. Anyway, because this notch is very critical, it has to face the correct way. So that must be facing in. So what I'm going to kind of do here, I'm going to just kind of soft set this for now. We can slide down in the rod and it's kind of roughly in place. Now we're going to do that with the 1-2 selector. Get this rod up and around there. Okay, that one's in, and that one's in. Also, on the note of directionality, this, let me get this a little bit closer so you guys can actually see. The 1-2 fork has this component on it where the selector grabs onto it. So of course, these two little arms that the selector itself will grab onto must be facing this side. So if you have the shaft flipped 180, then this will be facing the wrong way, and that's how you know. So what holds these in place is these little dowel pins, and they just press into place here. So I'm going to kind of soft set this temporarily. And we'll take our hammer, get that going. One down. Let's make sure that this one didn't shift while I was jostling all that around. Now we will soft set this. One, two, and reverse. Back in place. Now from here we need to put the detent springs back in. So those set right here, and that comprises of this nut which holds them all in, and then there's a spring here, and then on the very bottom there's a ball bearing that pushes up against the bottom part of the rod, the contoured part of the rod. I'll throw a picture up of that right here just to show you guys what I mean. I'm gonna put the ball bearing in, put the spring in, and then we're gonna thread in the retainer. Give it a little bit of tension. All right, that shaft is good. Now we're gonna do the same thing here. Put the ball bearing in, put our spring in. Okay, there we go. Done. We've got the forks back in place, which feels very nice. We can put the nose cone back on now, which is super exciting. That'll be the last step. So what I've already done is cleaned up the mating surfaces between the nose cone and the lower portion of the transmission. I did that off camera. This is one thing you want to make sure you definitely do, and do it thoroughly, because if you get this all back together and then it's not sealing correctly, then you're going to have to take it all back apart. Additionally, there is a sealant that goes back in place. It's a Loctite sealant. I'm actually not going to use the one that Porsche specifies. I'm going to use the one that they specify for engines, just because I know it works very well, so I don't see why it wouldn't work in this application too. But in order to have your sealant working properly, you need to have the mating surfaces very clean, of course. So I'm just gonna go across and degrease all of this one last time, just in case I got any grease on the mating surfaces, and then we'll pick up putting the nose cone back in place. The selector position is very critical for this job. So what actually we're gonna end up doing, I think, is pulling this selector back. And as you can see here, I've got this bungee cable to kind of fix the orientation this direction of this selector, and I think I'm going to try to do something. I'm going to like hook some string through it or something to hold the selector back this way, because that is apparently that's key in getting this nose cone to line up properly. We'll pick up with just a time lapse of me putting the nose cone back on. Hopefully I can successfully do so, and then we'll talk about it afterwards. And for the final touch, there. It's back together, everyone. Look at this beautiful specimen. So I kind of decided to sort of skip ahead with the time lapse, as you saw. I had some issues getting the cone back on. It was definitely kind of a pain, and it took me several attempts, so I just stopped the time lapse because it was just going to be a bunch of me humping around. But let me explain to you what it kind of took to get done. So what we ended up having to do was, you could maybe see my zip tie configuration that I had going on the side here. Basically, what I had done was I pulled the selector shaft towards this side of the transmission, towards these levers. Additionally, I realized that I was having trouble getting the little puck that this lever slots into on that selector arm. That was having trouble getting up and around. Something was needing to slot in place at the same time, or the same height rather, as what this lever's little puck was needing to slide into place on the selector arm, if that makes sense. So what I realized I had to do was actually, I pulled this lever up as far as it could possibly go, here, like this. It would have been this gear, so that this arm could be further up. And so what would have happened is, as we're coming down, that selector arm is now further up, it's latched into a gear, so then this lever's puck can slot into that gear before whatever else it was that needed to slot into place. So because I was having it, basically the bottom part of the nose cone was being pushed out and causing some misalignment.
Alrighty, let me just try to shed some light on what I was just trying to say. So this is the puck that I was referring to. This one is off of the end of the shifter arm and slots into this on the selector. And as you can see, there's an upper lip on that selector, which kind of becomes an issue when you're trying to put this all back together. That little puck must slip up and around that upper lip. So what I was trying to verbally explain is that you must have the selector in the correct orientation. And I found the correct orientation to be in what I believe is 5th gear. So you can see that if you look from the top of the transmission or down towards the table, we have the selector forced to be turned counterclockwise from its natural state. With it turned counterclockwise, when we slide the selector up, this puts it into 5th gear, I believe, which holds it into a higher position and allows us the room to maneuver the puck up and around it. And then that allowed whatever else it was that needed to slot into place at the lower level for the nose cone to be able to happen. I hope this provides some clarity. I just wanted to be able to supplement my explanation with some pictures here. Anyway, after several attempts, I was able to get it all aligned and get it set in place. And then I took quite a while. What I did was I left maybe an 1/8 of an inch gap. I was paranoid that I was going to lift it up too far and then get something out of place. So I left maybe about an 1/8 of an inch gap, and then I went around and dabbed on sealant with my pick here. I was able to just basically the slot that I made was as thick as this rod. So I would get my sealant, put it on the rod, and then just kind of dab it on. I did that all the way around and was able to get sufficient sealant on. By the way, I had mentioned the sealant earlier, but I ended up using this sealant. It's the Loctite SI 5900. That's not the Loctite that Porsche supposedly recommends for this application, but it is a Porsche bespoke sealant nonetheless, a flange sealant. So I figured it's for oil pan gaskets and everything. It even has a picture of an oil pan gasket, and it's also used for the valve covers as well on the M96, M97 engine, and probably other engines. So I decided it would be fine for this application. Maybe I'm wrong, but we'll see. Anyway, so we wrapped that up with throwing all of the 13mm bolts back in place. I torqued all of those to 30 Newton meters. Of course, there's so little information about this transmission out there, so I wasn't really sure what to torque those to. Shout out to Finn at A Man in a Garage YouTube channel. He has a great channel. If you've never heard of it, go check him out. He's a great guy, very passionate about Porsches, and also a newer mechanic, but he's done a lot. He's done a lot on his car, so go check out his channel. Anyway, he was doing something where he had to take the nose cone off of the transmission on his M96, and when he went to put it back, he decided, based on the typical torque range for 13mm head bolts, that he would torque it at 13 Newton meters. I agree with that logic, so I followed suit. We put the pin back in place, the detent for this arm here. That ended up getting torqued to 30 Newton meters as well. Anyway, all of this is back together now. We just need to wait for the flange sealant to set and cure. We are almost there, everybody. This thing shifts beautifully, as you can see. I'm so excited about it. Now all we need to do is get the thing back up in the car. Okay, so good news. Like I said, we're in that final stretch of transmission prep. So what I just did is I threw one of the two brand new plugs in it. I put the drain plug in the bottom, and then I set the transmission like so. This will be the fill plug once we're done filling the transmission. So we need to go ahead and do that first and foremost, fill the transmission. So I have it sitting, as you can see, nice and level, basically how it would be sitting in the vehicle on my table. I'm just going to pre-fill it so that we don't have to deal with doing that when it's up underneath the car. It's always a bigger pain to do, and we've got it right here, great access right now, so we might as well just do it. One kind of base assumption that I'm making is that the bell housing mating surface that goes up against the engine will basically be fully vertical in its normal operating state. And the reason I'm mentioning that is this is a fill to spill. Obviously the level is very important when we're filling this before the spill. So I'm going to get a level, make sure that we are truly vertical, and then we're going to go ahead and fill this puppy up. Once we're done with that, all we'll need to do really is put the throw out arm back in place, which I have prepped with some copper anti-seize for both the pivot point and where the slave cylinder pushes up against it. Just slot this back up into place and then move the transmission over to the car because it will be ready to go. Alrighty, well, here's the transmission. As it sits, it is fully ready to go back and up into the car, which is very exciting.
I just finished filling the transmission full of gear oil, and I also lubed up the splines on the input shaft there. Other than that, it is time to throw you guys on a time lapse and get this thing back up into the car. We quickly interrupt this time lapse to talk about that. All right, so check it out. We got our new half shafts. I know it's been a minute since we talked about this, but basically, as part of the two-wheel drive conversion, we needed to disassemble the front CV shafts, which turned out to be a complete pain in the butt. I did not realize this. I would have filmed it had I realized it's such a process, and I started Googling it and realized how many people have issues with this when they do this two-wheel drive conversion. And there's actually products out there that you can buy that's just this. The CV shaft with the little wheel speed sensor encoder and the splines, that's that, for $900. So anyway, obviously this is an issue that many people have encountered and are willing to literally spend $900 to just not have to do it. But let me tell you what I did really quick, and it's basically very simple. It's just kind of labor intensive. So I tried just about everything. I tried using a hacksaw, a sawzall, and none of it worked. Basically, so imagine your entire CV shaft is here. What I ended up having to do was I had to use my metal cutoff wheel here to cut the shaft, and that is the only thing that will go through that metal. I literally ruined a sawzall blade and a hacksaw blade by barely making any progress through that shaft because it is such hard metal. Anyway, so you have to use a cutoff wheel that cuts right through it like butter, but you have to make it really nice and short so that, let me show you here, so that this internal part can rotate. And you can see this from that. Once this is cut and it's, this is inside here, you can turn this about 90 degrees, and then you can take your ball bearings out. And then once you remove your ball bearings, that allows you to get this portion far enough, on the outside here, where it's facing out like that, because it holds itself in. It's literally a larger diameter than this very outer hole. So once I could turn that, then I could use my cutoff wheel again and cut this. As you can see, I cut this outer part, and then that allowed me to finally take it out. So anyway, we have a 1 hour solution to a $900 problem. There we go. We can just put these right back up in the car. Back to time lapsing.